Hi, welcome to Mystery Monday, or more precisely, Mystery Teardown Monday. I've got a whole bunch of mailbag stuff I've got in the mailbag for like little, kind of weren't worthy of a 2-minute teardown, sort of, you know, justified more than that. So I kept them on a shelf, and it's really overflowing. So I thought, like every Monday for a while, hopefully, I will just take an item at random from that shelf, a mystery item, and tear it down. It won't be a huge, extensive, half-hour teardown, but a little short thing. Yes, I'll still do Mailbag Monday when I get enough items and things like that. But anyway, what is the mystery item? Let's have a look. It's the Daton Bank, the Mega X Daton Bank. Thank you very much. Normally I keep the notes of who sent this stuff in, but I don't actually have that. So I believe we got this in a mailbag, and I don't think I tore it down in the mailbag, hence why I put it up on the teardown shelf. So what this thing is, I believe, I can't find any actual data on this module itself, but what I believe it is, and maybe it was in the original note in the mailbag, but I can't even find the original mailbag episode when this one was in, so hopefully I haven't torn it down yet. So I don't have any data on this thing. Maybe there was some info in the original note in the mailbag this one was sent in, but I can't actually find the mailbag episode it was in. Anyway, what I believe it is, it comes from a company called, where are they? ADP Gulzelmann in Germany. Hi to all my German viewers. And they're actually a gaming company. They manufacture like gaming, gambling machines or some such. And what I believe this is a secure memory / processing module that's designed to hold presumably the security keys or the encryption keys or whatever for the machine itself, and it's designed to prevent physical tampering of this thing. So if you try and open this and get out the encryption keys or whatever's encrypted inside this thing, then it's going to prevent you from doing that. It's going to automatically erase the keys and everything else. We've seen this before in like those FPOS terminal machines that you use at your local shopping center or service station or point of sale machines. They contain encrypted keys in them, and likewise they're kept inside a secure tamper-proof module like this. And of course you could potentially just try and hack the thing through the external pins like this, but these are designed to do all the secure processing. The encryption keys are kept in here, the processing, the decryption or whatever is all done inside this thing. So the theory goes that if you try and probe these pins, hack it in any way like that, you're not going to get any useful data out of it. You have to physically hack into this thing, crack it open, and try and get the encryption keys that way. But they're designed, if you crack this thing open, then the keys instantly erase themselves because they're held by battery-backed SRAM, typically, inside this thing. So, you open it up, boom, the battery, it loses memory to the SRAM, and boom, the keys are gone. So inside this thing, we expect to find some batteries, we expect to find some tamper-proof things, so if you try and drill through it or something like that, if you know exactly where to drill, because, hey, you could get one of these things, take it apart, and then figure out exactly what points to drill in, and then you could get yourself a good one with the keys in it, and then know to drill through. So I'd expect some sort of tamper-proof mechanism inside this thing, and battery-backed SRAM, and some processing, and stuff like that. But the interesting thing will be to see how they've done the physical security, because if you can't hack via the pins, which is the whole concept of it, then you have to go through physically. So this one's actually been opened, whether or not I opened it previously or it's supplied like that. So thanks to whoever sent this one in. So let's actually crack this sucker open, and hopefully we can see inside. It looks like I would have maybe expected them to weld it shut or something like that, but they haven't actually done that. They haven't done it, so we can actually get inside this thing. Someone's had a go at this. So let's, hang on, is that going to come apart? Yep, hey, hello. So, we've already, the keys are already gone, presumably. What do we got? We've got a board. Just got a copper board on there. Does that come out? on the top as well. So I think this is going to be some sort of... What's that? Oh, that's actually carbon put down onto the copper pad here. And look, ta-da! Oh, yeah, look, in the corners here, they've got carbon there as well. And these match up with these dots here. So they're making electrical contact onto this ground plane on the back here. So we'll get a meter and we'll just confirm that. And I betcha that is, yep, that is carbon, all right. There we go, 10 ohms or whatever. And that one over there is conductive as well. So yeah, they're connected through to this metal case here, and the same on the other side, is it? Yes, the same. Here we go. So exactly the same. So there, so the first protection mechanism here is if you take off one side of this, like this, presumably there's electrical connection through there, and it detects that you're actually removing the metal covers. So that's the first thing. So, hang on. Hey, hello. Hello. So that, ta-da, we're in like Flynn. Aha! Look. You can see the pattern on there. I'll get the macro lens out and we'll have a closer look at that. And I've got a contact there. And bingo, there's our battery. That's our battery there. And yep, it pops out. There we go. Exactly the same security measure on the bottom side. So here we go. They've got the batteries in there. They're going to have them soldered directly on like that for higher reliability. They've got 2 of them for redundancy, presumably. And yep, there's the little contacts which go through to the pad there. Yep, on the other side there. There's our processor, and we'll have a closer look. We've probably got some SRAM where the keys are held. Nothing's gunked at all. So I kind of expected maybe to see something gunked in there, like a physical protection. But the whole idea is once you remove these, it breaks the circuit. It might just be as simple as coming from the battery in series with maybe they look like there's traces in there, like that. So if you drill through, it's going to break those traces, and bingo, your SRAM, presumably, that holds the keys inside this thing, will just erase itself, and you've lost them. And bingo, there's our SRAM memory. These are Samsung parts, and SEC could stand for secure, but I couldn't find any mention of, you know, secure type application for these things in the data sheet for this. So, but anyway, these are KM68100 SRAMs, and normally they work from, you know, like 5-volt parts, but they're actually designed for battery backup applications. Exactly what we suspected here with the batteries, in that they retain their data down to 2 volts. So, of course, you know, 3-volt lithium cell like this, you want it to work down to lower voltages. So nominally 5-volt parts, and the system will work at 5-volt at 5 volts. It'll have a 5-volt processor and data bus and everything else. But hey, you can still retain the data on them down to 2 volts, and that's exactly what you need. And right next to the batteries here, there's a ancient looking part, 26-week 1985. So I'm not sure what's going on there, because a lot of parts elsewhere on the board are much later, as I'll show you. But anyway, R4543, that's a real-time clock chip. So this is, you know, fairly old tech in here. Here we go. So here we go. We're talking 14th week 99 there by the looks of it. So this looks like a 2000. Yep. Yep, 6-week 1999, so 2000 vintage. We've got ourselves an Atmel microcontroller here, old school 90S 1200. Do they even still make that one? Yeah, maybe. And also on the top side of the board here, a Max 691 voltage supervisor, microprocessor supervisor, so that would notify the processor when the power's removed and all that sort of jazz. And looks like, say, HC 573, Jelly Bean logic, regulator, yep, some more 245 Jelly Bean stuff, and there's our processor. I can see the Motorola symbol, but that's about all she wrote. So all of our So all of our secure key processing, everything else is done inside that baby, presumably. Yeah, I'm not sure what the little Atmel micro's doing there. That's rather confusing. So yeah, these SRAMs that are used to keep the security keys or whatever they're trying to protect inside this thing, these are just basically regular SRAMs. They're not secure cryptographic SRAMs and other memory products which you can get these days. Not sure if you could probably get them back when this was designed and manufactured, but they didn't bother to use those. Some of those, like the proper secure chips and secure micros and stuff, they will actually have like sometimes an extra security protection, hardware protection embedded inside the die itself. So they might have like a security mesh on top or something like that, so you can't physically try and get through the chip. Even if you could defeat all the other security measures inside this thing, you still couldn't get through to the chip itself. You've got an extra layer of protection yet again, but this one doesn't have that. So let's find out what this puppy is. Oh, it's not gonna peel off nicely, and it's got one of those silly unreadable codes, so I'll have to look at that under the mantis and get back to you. Is there a code there? Oh yeah, there's something there. And there's nothing special about that micro at all. It's just not the shelf one. It doesn't contain any hardware security measures on the die or anything else. It's not a specific security processor or anything like that, which might be used in the more upmarket FPOS terminals and things like, or other really serious ones. So anyway, that just does all the processing, and we're still unsure what that little micro there does. You know, some sort of supervisory role or something like that, perhaps. Now let's take a look at the security cover. Hopefully, you might have to watch this in HD. I can't really see it very well on my camcorder LCD here, but you can see the traces on the PCB there. So it's a PCB with all these circular, sort of like spiral traces on them, perhaps, is it? I'm not sure of the exact pattern. Anyway, that looks like it's just one conductive pad, but I don't think it is, because that wouldn't make sense. I think, yep, there we go. That is actually a zebra strip. There we go. That's a better look. That's actually a zebra strip that actually connects. Well, it's not the elastomer type one. It's different. You'll notice that there's conductive traces on there which go over very fine, and it basically connects all these traces in there. There we go. Got 4 traces, and so these would just be loop traces. So that looks like we've got 2 separate loops there, perhaps, and then these would likely, we'll follow the traces on the board in a minute, but my guess would be that these would be in series with the power line, power trace going to those SRAM chips. So let's see if I'm right. All right, it's actually hard to trace these things, but anyway, these pads go off to transistors and through these resistors. Here you can likely see that pad go off to these resistors. So all of this stuff in here, are those diodes or transistors? They could just be diodes, are they? Because that's a common way to switch, or at least some of them, a common way to switch in the power pins from a battery backed up SRAM. You just do it through diodes. One comes from the battery through a diode, another one goes via the main power rail. So when the power rail fails, the other diode kicks in and powers it from the battery here. Anyway, pin 8 over here, this is the power pin over here, and I have actually confirmed, we've got our buzzer on, I have actually confirmed that that doesn't go through to the power of any of the other chips here. So I've actually checked that. So they're not actually connected, so they are somehow breaking into the power pins of these chips, as you'd expect, because that's the whole concept, is that it loses the power. These are SRAMs, so they're a volatile memory. If you remove the power, bam, they're gone. You can't recover them. There's no residual anything in there that you can actually recover the keys from. They're just simply lost. So yeah, all this stuff around here seems, although I haven't figured out where the power actually gets back to over here yet, but yeah, it's definitely not connected directly through to the main power rail. But one thing I did follow is these two pads on the left side here, they actually go through, if you note the location to that physical hole there, they actually go through to the two pads on the other side. So it looks like it's one big loop on the top and bottom side of this thing. So if you remove either the top side or the bottom side, it's one huge loop going through all of these traces on the board. If you try and drill through this, if you physically remove it or anything like that, bingo, you're going to break the traces on there, and that will just erase, remove power to the SRAMs here, and keys are gonski. And as for the ground plane on the other side here, I think, and those bumps, I don't think that's actual connection at all. They're just grounding. They're just using that as an internal ground shield. Maybe it shorts out, you know, if you try and drill through or something like that. So there's some additional measure that, you know, shorts out the power rail or does whatever. Something like that perhaps, but it doesn't look like there's actually any connection to forming a loop between like the chassis or anything like that to actually detect it. But yeah, I could be wrong. You'd have to look into the exact detail. But yeah, I think all the security measure is coming from these things. And if you want to know the actual connection, it's not next to each other like this. It's alternate ones like that. So that's measuring about 100 ohms there. And it looks like we might have an additional security measure here. They've got one of these things which looks like a surface mount LED, but they've got one top and bottom here. And no, I've tried to light that puppy up and they aren't a LED. So that looks like some sort of maybe ambient light sensor. Whereas if you physically, even if you manage to somehow defeat all the loop protection and everything else here, you physically take it off and the light gets in to this thing, then bam, that's going to erase it as well. So maybe, yeah, the micro looks like it's controlling all of the security measures for this thing. So yeah, this looks like it's implementing some sort of smart security solution in that micro, handling all that. So that, you know, it's a bit more advanced than just, looping the power pins through the micro, through the top and bottom of these things. So it's a bit more advanced than that, so that's all right. So there you have it. There's a look at a security module for a gaming machine which does the processing that handles the encryption keys or something like that. If anyone knows the exact details of this, please leave it in the comments down below. But yeah, that's a rather primitive one compared to some of the more modern day ones that actually, as I said, have physical security features on the die, and there's various specialist manufacturers of these chips designed for FPOS and other high security terminals that, you know, have to keep the encryption keys secure from the factory, actually on the physical micro themselves with the built-in memory. They might have SRAM on there, or in this case, you know, fairly old school. I mean, this thing's at least 16 years old, you know, external SRAM memory like this, battery backup, and, you know, they've gone to a fair amount of trouble with the intelligent micro in there to handle all of the security, and just a physical shield like that connects over with all those fine looped traces to try and prevent drill through. So, you know, you shouldn't be able to hack these things through the external pins. So they would have, you know, you know, there's probably maybe even standards for this in the gaming industry or whatever that actually define, you know, the ability to, you know, not hack these things through the pins. So you'd have to, you know, go in physically to try and extract the keys or the data or whatever it is they're trying to protect. So there you go. That's a rather interesting look inside a secure memory module. And if you liked this new, well, don't know if it'll last forever, but I might keep it up fairly regularly, just a smallish teardown of a random mystery item from my very overflowing bench up there with all the teardown stuff on it. Anyway, like that's sent in via mailbag and various other stuff. So if you like that, please give it a big thumbs up. Oh, that's a big thumb. Catch you next time.